first time you deal with this kind of abstract proof. Alright, so watch. So everyone understand logic here? If it does converge, it has nowhere to go. It has to be 2. But there's still a possibility that it actually doesn't converge at all. Right? Okay? So, what should I do? In other words, the students actually score for what? Part B. But it doesn't touch on part A. It doesn't address part A at all. So, how do you know that AN is increasing? So here it comes. A1 is equal to what? Let's try to understand how this sequence works. What is A2? Huh? You take A1, which is square root 2, add 2 to it, and then take square root. And what is A3? You take the previous term, which is this one, I copy over. You add 2 to it, and then take square root. Alright? Do you think this one is greater than this one? Yeah? Which one is greater? This one or this one? That one, right? And between this one and this one, which one is greater? No. Yeah. So it looks like it's increasing. Is that right? Yeah? Can you prove? That's the thing. Alright? So watch. How do I prove this? Okay. So I'm addressing the part A here. Note that A1 is less than A2. Agree? Alright? Okay. Now, if AN minus 1 is less than AN, okay, observe that, first of all, regardless of this, would you agree that AN plus 1, AN is equal to square root, AN plus 1 is equal to what, according to that? 2 plus AN, correct? And how about AN itself? It will be square root 2 plus the term before it, which is AN what? Minus 1. Very good. Okay? So, since AN minus 1 is less than AN, assuming that, we have AN minus 1 plus 2 is less than AN plus 2. Agree? Yeah? And therefore, square root of this is less than square root of that. Agree? But what is this guy? What is that guy? What is this?
AN plus 1.
AN plus 1. So I have shown what? I.e., maybe if this is mysterious to you, here is the interpretation or clarification. So what I'm trying to say is that A1 you agree is less than A2, correct? Then I ask, is A2 then is less than A3? That's the next order of business. And so I say yes. Why? Because what is A2 anyway? A2 is square root 2 plus A1. And what is A3 anyway? A3 is square root 2 plus A2. But didn't you say that A2 is greater than A1? And therefore, A2 is greater than A1, and therefore this piece is greater than that. That exactly says that A3 is greater than A2. And therefore, indeed, this one is greater than that. Okay? So every step, you push just one step further. So from this, then you prove this. And then for exactly the same, using exactly the same strategy from this, you show what? A3 is equal to A4. Okay? And that's exactly what I'm trying to symbolically do here. What I'm trying to show is that whenever you have one inequality, the next inequality also holds. And then you have to get started. Is that right? Get started is